Okay, so should I start?
Yes, sir. Yes, sir.
Yeah.
Yes, sir.
See, basically, now we are starting with some prerequisite courses. Okay, prerequisites. Basically, for structural analysis, you have structural analysis course in this semester. Now, before understanding structural analysis, you need to understand what is a structure, right? And how to analyze a structure. What are the requirements for analyzing a structure? Why do you need to do structural analysis? Those things are very important. You should understand those things. And to make you understand about those and to give you a feel about the course, we'll start with some introductory concepts of structural analysis. Okay, now if you see the structural analysis, first thing, if you remember that last semester you have understood about solid mechanics course, right? So you have understanding about engineering mechanics and then solid mechanics. So basically the prerequisite of structural analysis is basically your engineering mechanics and solid mechanics. But before getting into the details of structural analysis, what you need to do, you need to understand the concept. What is the concept behind structural analysis? Now let us start with this one. The first slide, if you see that, what is a structure? So what is a structure? Basically you see that, you see the diagram. Can you see the diagram? So you see a skeleton, human skeleton is in between, right? So a human skeleton, if you think, it's a structure. That means what is a structure? Structure is something which actually carry different types of load. Structure is something which carries different types of load. You should understand this very well. So you see, if we think about our human skeleton, it is basically a structure. So human skeleton is a structure which actually maintains the shape of the body. And if you think that different parts of our organs, various organs, muscles, whatever it may be, our body is having, those are kept in proper place, right place, and the load of those things is transmitted down to the ground through the help of the skeleton. If skeleton is not there, we will not be able to carry the load of the muscles, our different organs and other things. So basically you see, our human body, if you think about our human body is a structure, and the skeleton is basically the structure which total human body is supported by, right? Now you see, every structure, if you think about every structure, think about this human body only. So what does the human body does actually? So if you think about human body, you see it deforms. Without deformation we cannot do anything, right? We'll have to eat, we'll have to run, we'll have to walk, whatever you do. So every time if you do something, if you try to do something, what you are doing, you are deforming the structure, right? And when you are deforming the structure, you see your deformation level, the deformation level of structure should be up to a particular limit. Beyond that, if you deform, then what will happen? There will be cracks coming. So if you can jump up to some level, but if you jump beyond that level and jump from let's say first floor, second floor of a building, then it is obviously that there will be cracks coming onto your bones. So your structure will be getting deformed to a such level that it needs to be repaired in such case. Okay, so one thing you must understand here, that is structure, the primary consideration of a structure is to carry the load. It needs to carry load, and when it will be carrying load, it will be obviously deforming. Without deformation you cannot carry load. Okay, and you also should remember that when the structure will be deforming, the deformation should be to such a limit that it cannot go beyond that limit, so that the structure fails. Fails means it deforms to such a limit that it cracks, that it bends to such a level that it breaks, and you need to repair it. So primary consideration, if you think, so if you understand what is a structure, so what is a structure, whenever you are asked to you are asked to answer this question, you must say a structure is something which carries different types of loads, and when it carries different types of loads, it deforms, and this deformation should be within a permissible limit. You cannot go beyond that permissible limit. If you exceed that permissible limit, then what will happen? You are going to disturb your structure, or you are going to disturb your structural form. Now coming to the civil engineering part. So now if you think about the civil engineering structure, then you see it's exactly the same like your human skeleton, how the human skeleton is working, right? So if you see a civil engineering structure, yes.
Sir, I think there is one ID, sir.
LV Pok sir.
Yes, tell me.
सर ये LV
कौन
Pok
सा
कौन है
ID?
सर, इससे पूछिए.
Which one?
Sir,
Class नहीं है सर.
Someone is there.
LV Pok sir ID.
Which
Yes sir,
one?
LV Pok ID कौन है सर, इससे पूछिए.
Which one is I? Let me see. I cannot go down. Anyone is trying to enter?
Yes sir, LV Pok.
So now I cannot see. 25
He's
people.
already there, sir.
I cannot see that. How can he enter without the permission? Where is the ID? Where is the ID? Let me check.
शायद ये क्लास का ही है.
Hmm?
सर स्क्रॉल डाउन कीजिए ना सर.
Scroll
क्लास
down.
का ही कोई है सर.
रुको बता रहा है कौन है.
If I scroll down.
लिटन बर्मन है क्या?
हाँ सर, I'm Liton Borman. I am LB Pok.
Return one. Okay.
भाई सही नेम लिख क्या हो यार.
You put proper name, right? You write proper name. Your name only you put in the this thing. Don't put any other name. Okay. Liton. Yeah.
Okay, sir.
Okay. What is this name? Why everyone is seeing this thing? You write your name properly. The Liton, you write Liton Borman in your name. Everyone should write their own name on their profile. Okay. So let us proceed.
Okay, sir.
Okay. Yeah. So now you see, if you think about the civil engineering structure, and if you think about solid mechanics also, then you have studied about beams, you have studied about deformations, all other things, right? So if you see a civil engineering structure will also carry different types of loads. Now you see, different types of loads means this kind of loads civil engineering structure carries. You have learnt about in your solid mechanics course also the axial forces. The axial forces may be tensile or compressive. Then flexure means bending, so bending kind of forces. Then shear and then torsion. All these things you have understood in your solid mechanics course. So a structure will basically carry different types of primary load, and it's not that only tensile, only compressive, only flexural, only shear, only torsion will be subjected, a structure will be subjected to. It may be as well as the combination of various types of loads, right? So a structure, civil engineering structure may come into picture which will be carrying axial load as well as bending. It will be carrying bending as well as shear. It may be carrying bending as well as torsion. It may be carrying bending, shear as well as torsion. So it may be combination of various things. And if you think about your human skeleton and human structure also, you see, we also carry different types of loads. So when we throw a ball, basically when we throw a ball, what we are doing, we are stretching our hand, right? So it's a tensile kind of force. When we are pulling something, we are stretching it. So some stretching amount, so some kind of pulling is coming and some muscles are getting compressed. Okay, so everything, whenever it is happening, it will be just getting combination of everything. It will be getting combination of everything. Okay, so if you are trying to allow, if you are trying to allow something, if you are trying to allow the load onto a structure, then you must understand there will be deformations coming onto the structure. This you should be very very clear about. So everyone can see the presentation, you can see in your screen, or should I little bit enlarge?
Yes sir, yes sir.
Should I enlarge
sir.
little bit?
Yes.
थोड़ा सा बड़ा करेंगे इसको,
नो सर ठीक है, नॉर्मल।
यस
ठीक
थोड़ा
है।
बड़ा कर दीजिए।
थोड़ा बड़ा करें, ठीक है। ज़्यादा बड़ा करेंगे तो स्क्रीन से बाहर चला जाएगा, वही प्रॉब्लम। नाउ इज इट ओके?
यस सर।
Yes, sir.
So now you see how to determine this deformation, how to determine the loads coming onto the structure, how to determine what is happening because of the load coming onto the structure. That is the part you need to learn in the structural analysis course. So if you want to learn about how does the deformation happening to a structure, or how does the structure is behaving because of the external load, so in such case what you will have to do, you will have to strip down the structure to its basic skeleton. So you will have to first take a structure, whole structure, and then you will have to take part by part of the structure, and then you will have to separate it out and break it into a basic skeleton, and then you need to analyze the structure. Now let us go to an example. So see this one. So can you see this screen? Now
Yes,
you
sir.
see this is basically a typical example of tension and compression. It's not a civil engineering structure as such we are saying. Okay. Now you see, can you see that first diagram, this one, you see that rock climbers are climbing the rocks or the mountains. Okay, and you see one person, two persons have climbed up, and the third person is being pulled up, okay, by the two persons. So what is happening in this case? You see the pulling is happening through this cable. Can you see? Pulling is happening through this cable. So when a person is hanging from this cable, what will happen? What will happen? There will be some kind of tension coming onto this cable, right? So a climber, when it is suspended from a cable, the two persons will be handling these two cables. They will be feeling a huge amount of pull from this person, and this pull will be taken by these two wires. So you see the amount of pull, whatever is coming, that is actually tension. And this tension, if that material of the rope cannot take, then what will happen? The rope will break, and once the rope breaks, be it from this side, be it from this side, what will happen? This person will fall down. So what will happen? The total structure, the total structural assembly will fall down. So this is the very important part you should understand from the perspective of deformation. So see, this is a kind of structure, you can think about it, and this is a kind of a structure where one wire is used to pull a person. So the tension forces are coming onto these wires. Tension forces are coming onto these wires. However, if the tension is exceeding the limit, permissible limit of the tension which the wire can carry, this structural assembly will completely fail as a whole, right? So suppose it breaks from this side, this person will fall down, right? So what will happen? This total structural assembly will fail in that case. Now go to this example. See, you may have noticed it in many cases in circus. See, one elephant comes on top of something and two persons are just holding it above. So the load of the elephant will be giving, what it will be giving? It will be giving kind of compression. So compressive forces will be coming, and see, these compressive forces are being taken by this person and this girl. So what is happening? There will be huge amount of compressive forces are coming. If they cannot take that compressive force, what will happen? The platform on which this elephant is standing, it will just come down and it will smash these two person. So if the smashing needs to be avoided, what will have to do? The amount of compressive force this structure needs to take. Another beautiful example, you see the spider's web. You see the spider's web. Can you see? The spider's web is a very good example of a tension structure. So you see all the small grids what the spiders make. Those grids are basically the wave, whatever the wave the spider makes, those are basically kind of tension structure. And whenever there is a tension, this tension can be easily taken up by those waves. Okay, and inside that wave only, the tensile structure only, whenever anything, any small kind of insects comes, they can catch that using that tensile wave. And the tensile wave is prepared in such a way that the tensile structure does not get disturbed and it does not fail. So you see, deformation and load is such a related thing. Whenever there is a load coming onto the structure, there will be deformation onto the structure, and you will have to make your deformation restricted to such a level that it does not go beyond a permissible limit. If it goes beyond a permissible limit, the structural assembly will be failed. And you should understand this point very clearly. If one point of a structural assembly fails, then the total failure of the structure is started, and gradually, because of the single point failure of a structure, the total structure may get failed. Now go to the next example. Let's go to the next example. It's a very good example, you see. And a monkey is trying to go up to a tree and he tries to eat that fruit. So what it will do? So you see, this monkey will climb up this and that, and it will go and it will catch hold of this. So what you will see? What are you seeing from this? What is this example showing you? Basically, you see this example. This example is showing you. This example is basically showing you that all materials and structures deflect. Whenever there is a load coming to a structure will deflect, and the extent of deflection will vary. Sometimes it will be very huge, sometimes it will be lesser. So whenever there will be load, there will be great variation of deflection, and the deflection should be controlled. It should be controlled to such a level that it should not go beyond some limit. And you take this case of example, take this example of monkey. So when this monkey is going, see, at this situation, when the monkey hasn't climbed up this what is called this branch, then you see it is almost straight. Now when this monkey has went up and caught hold of this fruit, you see this branch has got bent, right? It has got bent. Now this is the basic science of elasticity, which you have understood in your strength of material course or solid mechanics course. The science of elasticity, this is the science of elasticity. You see, this tree, this branch was straight here. Now when the monkey is coming, because of the load, you see there is a bending, and this is actually the science of elasticity. It didn't fail. However, what has happened? It has got little bit bent. Whenever the monkey will come out of this, again this this structure will come back again, this branch will come back to its original shape, right? And this is the theory of elasticity. You will see, this is the science of elasticity. So the science of elasticity is about the interaction between the forces and deflection, and that is the point we need to study in case of our structural analysis. So we will be studying the elasticity part in terms of the forces and deflection. So we will be studying what are the forces acting on a structure, and because of those forces how the deflections are happening in the structure, and whether those deflections are within the permissible limit of the structure. Now you take this example. So you see, what is the load? The load is the monkey in this case. What is the structure? The structure is the tree and this branch. Now what is happening? The bending is happening to the structure. You see, this branch of the tree is getting bent. So bending is happening to the structure. You have studied about bending in your solid mechanics course, bending moment and shear force, right? Now you see, because of this bending, what is happening? Because of this bending, what is happening? You see, the top portion of the branch is getting under tension, right? Top portion of the branch getting under tension, whereas the bottom portion of the branch getting under compression, just like a cantilever beam it is happening. Can you understand? So see, this is a structure. This structure is bending because of the load, and load is given by the monkey, and this monkey is bending the tree, and because of this bending there is a deflection coming, and the deflection is such that top portion of the branch is getting deflected such a way that top fiber of the top portion of that branch is under tension, and the bottom portion of the branch is getting under compression. And you see, this deformation and deflection is coming, it is to a maximum level where the monkey is sitting. You see, this portion the monkey is sitting, and the deformation, you see, from here to here, if you notice, the deformation is maximum where the monkey is sitting, and this is what is cantilever beam, and this is what is structure. So you should understand this very clearly. So it's a very good example you can understand, right? So you see, if another 3 monkeys come here, you see, say it may happen that bending will go to such an excessive level that this branch may fall down, okay? Or it may happen that another 2 monkeys come and they are sitting over here, and this monkey is giving and catching hold of these fruits and giving it to the others, then they can get the fruits without disturbing the structural deformation or without disturbing the structure to fail, okay? Now let us go to the next slide. Now you see, so you see, what does now have you understood what is the structure, and you now try to understand what does the structure do. So if you understand what is the structure, you understand what does the structure do. What does the structure do? A structure does nothing but carries the load. A structure does nothing but carries the load, right? And the loads acting on the structure, whatever loads acting on the structure, you can broadly classify those loads under 2 categories. The first kind of load is the dead load. Now what is the dead load? The dead load is kind of load which the structural weight itself is having, that means which is not moving at all. That is the dead load. That means if you are constructing, suppose, a concrete beam, then the weight of the concrete, weight of the reinforcement together will give the dead load of the structure or dead weight of the structure. Now only the structure, whenever you will be constructing a structure, it will not be only under the dead load, it will be also subjected to service condition. Service condition means after the construction of the structure, some kind of the structure will be put for some kind of working condition. That is actually called service condition. And during the service condition, you see, the structure will be subjected to live kind of loads. And what are the live load? It's very simple. We are the live load. We are sitting on the structure. We are running here and there. We are moving here and there. So people will be considered as live load. Equipment means the furniture, the computer table, the sofa, the almirah, everything will be considered as live load onto a structure. the machineries which are put on the floor, they will be considered as the live load on the structure. See, don't consider almirah as a dead load, because you see the position of almirah can change from one to another place. One day you can place your almirah at one floor position, and on the other day you can bring it to some other floor position. A sofa you can keep it at one position, and on other day you can make it you can change the position of the sofa to other place. Okay, so you see, any kind of equipment, any kind of things we are using for our daily life usage, those will be considered as live loads on the structure. Now these are the very two common types of live loads acting on the structure: we the people and the equipments, or the different kinds of facilities, or the things we are using for our daily lives. But other than that, there are primarily another three kinds of live loads which are very, very important, you must consider while designing or analyzing a structure. And those live loads are very, very important. They are coming from the nature. And the natural live loads, if you see, they are basically the wind load, the wave means the sea waves, okay, and the seismic loads means the earthquake. See, these three things are not in our control. See, you can control the people, you can control the equipment. So live loads can be controlled by you and me only to the extent of people and equipment. We cannot control the natural live loads like wind load, seismic load, and the sea waves. They are beyond our control. They are coming from the nature. Okay. However, as civil engineer, it is of a great concern for us that we must consider this load while analyzing a structure as well as designing a structure. If you do not consider these kind of loads, you may be going for a catastrophic design, because you design a structure without wind load consideration, without seismic load consideration, without the sea waves, effect of sea waves consideration, then there may be a there may be a chance that if a earthquake comes, and if your structure has not been analyzed and designed considering the seismic load, in such case your structure must be failing. So you understand this is a very, very important point. So dead load is very easy to consider. Dead loads are very easy to consider, because you see, dead loads are not moving at all. So you can just, from the dimension of the structure, you can calculate its dead load. If you know the density of the structure, if you know the unit weight of the structure, you multiply the volume of the structure with the unit weight of the structure, you are going to get the total weight of the structure. That is very easy to calculate. But live load calculation is very difficult. And live load calculation, when we will be doing, see, it's very easy to control people and equipment. However, you cannot control live loads which are coming from the nature, as I have mentioned. And you should be very cautious about designing of a structure or analyzing a structure for these kind of live loads. Is it clear? Now let us go to the next point, that is, the structure will be carrying different kinds of loads, that you understood now. And because of these loads, there will be deformations, right? Because of dead load, structure will deform. Because of live load, structure will deform. So because of people weight, structure will deform in some way. Because of wind, structure will deform in some way. Because of seismicity, because of earthquake load, structure will deform in some way. So deformations will come into the structure. So how do I find out? How do I find out the total deformation of the structure? Because I need to find out the total deformation of the structure. When a structure is subjected to all these loads together, then what will be the total deformation of the structure? If I could not find out the total deformation of the structure, then what will happen? Then I will not be able to find out what is exactly happening to the structure. Suppose if I separately understand the deformation of the structure, then I will not be able to say whether my structure is safe because of that deformation or not. Just for example, I tell you, suppose you have taken a simple supported beam. Now simple supported beam will have some dead load. Now if with this dead load, if you calculate some deformation, that deformation will give you some value, and when that simple supported beam again will be subjected to some kind of live load, or some kind of people is dancing on that beam, or some equipment you are placing on that beam, then what will happen? There will be more deformations coming. So the structure, that beam, need to take the deformation of the dead load as well as the deformation coming from the live load, and the total deformation you need to calculate, and that can be calculated very easily using the principle of superposition. And principle of superposition, if you remember, while discussing about solid mechanics, I have given you some idea about principle of superposition. I will discuss it in my next slide. I will discuss it, what is principle of superposition. Okay. Now you see, now if you want to keep your structure, if you want to keep your structure safe, if you want to keep your structure safe, that means the structure should not fail. In such case, you must be considering two kinds of equilibriums. One is the static equilibrium and the other one is the dynamic equilibrium. Okay. Why? Because you see, the dead loads, the general dead loads and the general static kind of live loads. Static kind of live loads means people are sitting, almirah is sitting, and your chair is sitting, your sofa is sitting on the floor. Those can be considered as static kind of live loads. So if you think about, you will have to consider the structural safety from those loads. So static kind of loads needs to be considered, as well as you will have to consider the dynamic equilibrium. So dynamic equilibrium means the loads which are dynamic in nature. You see, the wind is a dynamic kind of load, the earthquake is a dynamic kind of load because with time the forces will change, right? So you have understood the dynamic load concepts in your engineering mechanics course. So this dynamic equilibrium also needs to be satisfied while analyzing a structure and designing a structure. Okay. Now the structure basically transfers the load to contiguous structural components. See, you are putting a beam and you are putting two supports. So how do you make a supports? Let's think about a simple frame. So if you think about a simple frame, then you see two beams and two columns. So what will happen? The beam will be taking the load, and through the beam the loads will be transferred to the column, and then through the column the loads will be going to the foundation, and ultimately it will be transferred to the ground or the rocky stratum. So that is actually the transferring of load to contiguous structural elements, structural components. So if you are making a beam hanging on the air, it cannot support anything. So you will have to prepare, if you will have to make a proper supporting mechanism for your structure, so that the structural elements are supported in such a way that whenever the loads coming to the structure, the deformation will be in a permissible limit, and the loads will be transmitted through by some means to the ground level or to the rocky stratum. And you must remember, this load transfer must be happening safely to the foundation. So this safe transfer of load to foundation you will be learning in this semester only in your foundation engineering or soil mechanics 2 course. Okay. Now coming back to the superposition principle. So what I have said about superposition. See, because of dead loads some deformation is coming, because of different kinds of dead loads deformations are coming, because of different kinds of live loads deformations are coming. So how do you calculate the total deformation? So if you see, this is actually your principle of superposition. So what is principle of superposition? You see, very simple principle of superposition. Let's say your structure, this is a simple supported beam. Let's say this is a simple supported beam. Can you see? This is a simple supported beam. You see, because of this point load and because of this trapezoidal kind of load, uniformly varying load, this structure is subjected, a deformation pattern of this kind is coming. So you see, principle of superposition is nothing but you can just forget about different kinds of load and you consider one by one load together, one by one load separately. So you see, the total structure is supporting two loads, this load and this load. One load is your point load and one load is your this uniformly varying load. So if you want to find out this yx means the deformation at different points of the structure. If you want to find out this, then what will happen? Who is
Fake
this?
account है.
There is
Fake account.
there is a photograph is also coming. You remember this
Fake account
fellow?
है.
सर फेक है सर, फेक है,
Denying.
फेक है
वर्मा
सर.
का फोटो है सर, ये अकाउंट फेक है सर.
I deny. I denied. Okay, forget about it. So you see this structure, this beam, when you are subjected to a point load and uniformly varying load, you see what is happening. You are basically summing it up, right? You are summing it up. So you calculate the deformation because of this point load separately. So you remember Macaulay's theory? Everyone? Anyone? Last semester we have studied about Macaulay's theory.
Sir,
Deformation calculation. You remember?
Sir, EI D square.
Yes. So point load and this for those you have calculated d2i dx2, some deformation calculation, integration, double integration method you have studied. So see, for this point load you can calculate the deformation, and for this uniformly varying load you can calculate deformation. So at every point you should be able to calculate deformation in terms of the function y of x. And if you sum it up, so your yx, you see this yx is going to be just nothing but the equal to this y1x plus y2x. And what is y1x? y1x is nothing but the deformation because of this point load. And what is y2x? y2x is nothing but the deformation because of this uniformly varying load. So you see, principle of superposition is very simple thing. So what it actually says, theoretically, if you see, I have written this thing, principle of superposition. If you see the definition, so the total displacement of any structure, so total displacement. So when you think about displacement, you see displacement may be because of internal loading, displacement may be because of the stress. So the total displacement at a point in a structure, any structure, the total displacement subjected to several external loadings. These several external loadings may be several kind of dead loads, several kind of live loads, several kind of dynamic loads, whatever it may be. So several external loadings can be determined by what you will have to do? By you will have to just adding together the displacements. You will have to just add together the displacement or internal loading stresses caused by each of the external loads. This is very important, each of the external loads. So you calculate one by one for each of the external loads, you add together and you are going to get the total displacement of the structure. Okay, and you must understand this displacement relationship must be linear relationship. That means your Hooke's law must be valid. If it is going beyond Hooke's law, then this linear relationship will not be maintained. So you cannot Anik Maharatno.
Fake ID.
Anik Maharatno is one of the students,
Fake
right?
ID, sir.
Fake
Fake
ID.
ID, sir.
Civil 1, sir.
Yes, sir.
Denied. Because everyone should come, because we have given all the IDs, so everyone has got permission, right? So they can enter, so no one should be permitted. Forget. So now you see this linear relationship must exist, you must understand. So principle of superposition will be only valid till the Hooke's law is valid. Okay, so materials must behave in a linear elastic manner. It must behave in a linear elastic manner. If it does not behave in a linear elastic manner, you cannot use the principle of superposition. You must understand it very clearly. Okay, so whatever structural analysis things will be learning in this semester, okay, all the structures will be considering there within the elastic limit, and the Hooke's law is valid for all the cases. Okay, so to apply this principle of superposition, if you want to apply this principle of superposition, there will be two requirements that must be satisfying. One is the material must behave in a linear elastic manner so that the Hooke's law is valid, and the second thing is the geometry of the structure must not undergo significant change. You see, I have given you that example of that monkey. You see, the geometry of the structure has not gone significant changes. It has bent, and then what will happen? When the monkey will go away, then again the branch will come back to its own position. So the geometry of the structure should not go significant change. Okay, so if it goes for a significant change, then you see automatically there may be violation of Hooke's law. So the geometry of the structure is also very important. So the geometry of the structure must not undergo significant changes when the loads are applied. That means the small displacement theory should be applicable. That means you see, whenever you are considering the deformation of a big beam, you see the deformation is coming in millimeter. Let's say 5 meter beam, at the center it is deforming by an amount of millimeter, right? It does not go for a deformation of meter. If it goes for a deformation about a meter, then the geometry will not be considered to be same as the previous geometry. So that means actually, if you see that bending theory, whenever you understood that the section, that any section remains plane before bending and after bending, that is true. So the geometry of the structure must not undergo significant change when the loads are applied, and the small displacement theory must be considered while you consider the principle of superposition. Okay, so now you see just a simple example. Let us take, this is your building structure. A building structure, you see, it's a very simple example, the whatever points we have discussed. Okay, so this is a structure, you see, and in this structure you see the snow is coming. Let's say it's in some snowy region. So on the rooftop you see snow load is coming. So snow is kind of dead load or live load. Which kind of load it will be? Anyone?
Dead load.
Dead load or live load?
Live load, sir.
It will be live load,
Live load, sir.
because you see snow is not going to remain for every time, right? Maybe during winter season when the snowfall is happening, then snow will come, and one day snowfall will be more, one day snowfall will be less. So this is going to change the pattern, right? Pattern of loading is going to change, right? So snow is basically live load. Okay, so snow will be considered as live load. Then you see the water tank. So water tank is there on the floor. So it is live load, because water tank sometimes it will be full, sometimes it will be half full, sometimes it will be empty. So it will be live load. Okay, then you see there are computers, there are furnitures, right? There are people moving on the floor, there is car, there is some storage. All these are live load or dead load? These are all live loads, right? These are all live loads, right? And you see the structural elements, this roof of the structure, these columns of the structure, these beams of the structure, these are the beams of the structure, these are all dead loads, right? So you see, a dead load, a total structural element which is having dead loads, they are supporting basically different kinds of live loads, you see. snow load, load due to water tank which is live load, computer, furniture, and then people. And you see the wind is also coming from one direction, right? So wind load, is a dynamic load, so this structure will be subjected to wind load. If suddenly the earthquake comes, this structure will be shaking, so the structure will be subjected to earthquake load, so dynamic load. So structure will be going through another one live load, that is earthquake load. Okay. Achilles Prajapati,
फेक आईडी सर, फेक आईडी
एक आईडी
Fake ID है सर।
कोई घुसने का ट्राई कर रहा है, ठीक है, स्टॉप इट. Okay, now you see what this structure will do. So these are the structural elements, you understand. So this is a total structure. So structural element, you see what are the structural elements for this structure. See, this one is beam, this one is beam, this one is another one beam, this one is column, this one is column. There is a slab on top of these, there are slabs on top of these, or some beams are supporting the slabs on top of this structure. So you see these beams, columns are basically your structural elements. Now you see these structural elements are going under the ground, and what is this? This is actually your foundation. So you are preparing a foundation, and this foundation is placed in the ground level, and finally you see these foundations are basically transmitting this load through the soil to the rocky stratum. Is it clear? So this is how a structure will behave. So the total load whatever will be coming to a structure will be just getting supported by foundation, and the foundation will be ultimately transmitting the load to the soil through the rocky stratum on the ground. And this is how a structure will transmit the load. So you see the contiguous element we have spoken about, and these contiguous elements are nothing but this contiguous elements means this. See, from this roof slab the loads are coming to these beams, from these beams the loads are coming to these columns, from these columns the load is getting transmitted to the foundation, from this foundation the load is getting transmitted to the soil, and from the soil the load is getting transmitted to the rocky stratum. And this is what is actually a complete structure looks like. Okay, and you will have to consider element by element analysis of this structure. So whatever we will be learning in this course is basically the elemental analysis of structure during the learning phase of this course. Okay, just I will take another 2-3 minutes and we will go to the slide number 9. So see, I'll not get into this in more detail, just little bit I'll tell about this, and then again from the next class tomorrow I'll discuss more in detail. So you must now understand what is structural mechanics and what is structural analysis. Just I am going through this, I'll explain it tomorrow in more detail. So mechanics, you see, you have learnt about mechanics, right? So in the mechanics, what you have learnt about the behavior of physical bodies. You have learnt about behavior of the physical bodies when it is subjected to forces or displacements. And in such case, you see, as a body as a whole you have considered, right? Total body as a whole you have considered for your analysis for mechanics. And in that mechanics you have studied about statics and dynamics. So bodies at rest or moving with uniform velocity, that is actually static, and bodies which are accelerating you have studied under dynamics. And then you have studied about strength of materials or solid mechanics, where you have learnt about deformation of bodies under the forces. You have learnt about deformation, how the bodies are deforming under the forces, right? And then comes your structural mechanics. So what is your structural mechanics? Structural mechanics basically focuses on the behavior of the structures under load. So behavior, how the structure will behave under the load. So this analysis is basically a process by which an engineer will determine the response of the structure And what is the response? Response is nothing but the deformation response, the stress response, the internal deformation response, the internal stress response, the internal shearing response, the internal bending response, the external deformation response. So all such kinds of responses needs to be studied by a structural structural engineer, subjected to different kind of specified loads and actions. And finally the response needs to be studied. So magnitude of force development and magnitude of deformation needs to be understood. So how the forces are developing and how the deformations are happening, we will have to study about it. I will discuss about this collapse and serviceability in the next class. You will be learning more about this collapse and serviceability while you will be studying the course of reinforced concrete design, which you have in this semester only. But I will give you brief idea about collapse and serviceability in tomorrow's class. So I think we stop here today, and if you have any question, let us see. If you have any question, is it okay, everyone?
Yes, sir.
Is it
Yes,
okay?
sir.
So
Yes, sir.
yeah, tell me.
Sir, hinged window and doors are live load or dead load?
Pardon? और एक बार पूछो.
Sir, hinged windows and doors are live load or dead load?
See, windows will be considering as general doors windows will be considering as dead loads, okay, general doors windows, okay. But hinged, whenever it is hinged, okay, whenever it is hinged, it will be coming under consideration of live loads. But I'll explain it tomorrow. There are Indian standard codes, okay, there are Indian standard codes, that is actually Indian standard code 875, okay. So Indian standard code 875 specifies about what are the things you should be considering for dead load and what are the things you should be considering for live loads. This 875 code has got different versions, part 1, part 2, part 3, part 4, part 5, okay, and these different parts speaks about different kinds of loads. And for calculation of the earthquake load also, Indian standard gives another one code, that is called Indian Standard Code 1893, okay. So tomorrow I will discuss about little bit about these codes, okay. So see, whatever Indian Standard Code will say that this thing you consider as dead load and this thing you consider as live load, you will have to go with the Indian Standard Codal provision and you will have to consider those loads accordingly. See, it is difficult to find out the live load, right? So how do you know in a hospital building how many people will come and roam about? How do you know in a multi-story complex how many people will be coming and running about? So all these things are studied, and using statistical analysis data, a particular load per kilonewton per meter square, per square meter area, how much load may be maximum coming on a structure, considering it is a live load, that is being specified in Indian Standard Code 875. Is it clear? So I'll request you can just download your from internet 875 codes 1 or 2, 875 part 1 and 875 part 2. You will be able to understand very easily what are dead loads and what are live loads, okay. Tomorrow if possible I will show you 1 or 2 pages of Indian Standard Code 875 and 875, then you will have clear idea about it, okay. Okay, any other question? So your yes
सर 45 में भी एक क्लास शेड्यूल था, तो वो क्लास होगा क्या?
which one?
सर वो टाइटल नहीं था उसमें,
Which one? 245?
टाइटल नहीं था उसमें।
टाइमिंग बताओ ना, टाइमिंग
245 से
दोनों क्लास तो तुम लोगों का इसमें ही दिया है 12 to 1. Tomorrow again 12 to 1 class I have given, right?
सर एक इनविटेशन था जिसमें
नहीं,
कि
वो
कैंसिल हो गया सर,
invitation-
कैंसिल।
26
वो कैंसिल किया, मैं मिस्टेक से कर दिया था। सिविल 1 को सिविल 2 का क्लास भेज दिया था, सिविल 2 को सिविल 1 का क्लास भेज दिया था बाय मिस्टेक, फिर उसको कैंसिल किया। सी योर स्ट्रक्चरल एनालिसिस क्लास विल बी ऑन 12 to 1 संडे एंड मंडे, ओके? इज इट ओके?
Okay, sir.
यस सर
अभिषेक,
Thank you,
संडे और
sir.
मंडे 12 to 1, ओके?
Yes, sir.
So see, I will give one quiz, okay? Four questions quiz. You just fill it up like the previous classes you are doing. Huh? Submit. Huh?
Yes, sir.
Okay. Okay. So other classes are happening properly.
sir.
Other classes are happening, Abhishek.
Yes, sir. Yes, sir. Happening, but a lot of disturbance is there, sir.
No, disturbance means what kind of? These many people are trying to enter on this or some other thing.
Yes, sir.
So
Yes,
you,
sir.
so we'll restrict this way. Today's class no one could disturb, right? So
Yes, sir.
I think invitation needs to be sent using this invite link, so no one with other
Yes, sir.
other email IDs can enter, right? Correct or not?
Yes. Yes, sir.
Okay. Okay.
Correct, sir.
Okay.
Thank you, sir.
Thank you then. Okay. Okay. See you.
थैंक यू सर
See you tomorrow.
Thank you, sir.
Thank you.
सर अटेंडेंस सर अटेंडेंस
अटेंडेंस तो वो गूगल स्प्रेडशीट भेजेंगे, उसमें दे देना सब लोग, ठीक है? उसमें क्विज भेजेंगे 4, उसमें आंसर कर देना, अटेंडेंस रिकॉर्ड हो जाएगा उसमें।
ओके
ओके? हाँ हाँ, ठीक है, ओके।
Hold it, hold it, hold it.